Okay, this video is for my Calculus 1 class, and we're talking about optimization. So this is Optimization Lab 2, number 3. So a box company produces a box with a square base. So let's draw a box with a square base. Pretty good, if I should say so myself. That has a volume of 8 cubic feet. So it must be an open top one. I didn't say that, but so the volume is 8 cubic feet. Material for the bottom. So here's the bottom of my box right here. So the material for the bottom right here costs $6 per square foot. So first of all, before I do that, I'm going to call this X by X because I did say it was square, that the base was square. And now they're going to say it's going to cost to do the bottom $6 per square foot. Okay. So once I find the area, I can multiply it by 6 and that'll tell me the cost. And the materials for the sides cost $3. So here I'm going to do the sides are going to be $3 per square foot. And the only other difference is they didn't say anything about the height, so I'm just going to call it H. So like right here is the side of one of the boxes. So let's look at what it has here. It says find the dimensions that minimize the cost. Well, first of all, I'm going to put constraint. So what is the constraint? Well, the constraint is what they told us is the volume. So the volume of this box is our constraint because it has to be 8 cubic feet. The objective is they want us to create a box out of material that minimizes the cost. So it's going to be the minimal cost is what we're looking at for our objective. Okay. So first of all, let's set up what we're going to do for a constraint equation. So I know that the volume of a box is area of the base, or a shape is area of the base. That's a big B times the height. And the base is x squared because it's according to my picture, because it's a square. And then I know the volume has to equal 8. So this is my constraint equation. Right here, I'm going to actually solve for h right off the bat because I don't want to solve for x when I put this in my objective equation. I could, but I'd have a square root and the math would be, it'd be more difficult, okay? Now, my objective is I want to minimize the cost. Well, a cost equation is basically, if you think about it, if you're talking a material of the box, you're talking about the surface area of the box with money. That's what the cost is because you're looking at whatever the box is made out of. And it looks like the base is a little bit more substantial because it costs more for the base than it does the sides. So let's do the surface area, and then I'm going to add the money to it in a minute. So I'm going to use this as green. Well, the surface area is the base plus, so that's the area of the base, plus I've got the side. So one side here is XH, and I have 4 of them, so I have 4 XH. So that's the area of the surface, okay, the surface area. Now I'm going to add the money. Well, how much does it cost for the base? $6. So that's 6 times the area of the base. And then I'm going to move this plus over here a little bit. And then I look, it's going to cost $3 for the sides. So it's going to be $3 times this. So I have my $6 here and my $3 here. So when I get done with my cost equation, it's going to be 6x squared plus 12xh. All right, so there's my cost equation. Now I'm going to take this right here, my h, plug it in this spot right here so that everything's in one variable. So I have 6x squared plus 12x times 8 over x squared. Okay, now I'm going to continue on simplifying this. So I see this crosses off. So I have my cost comes out to be 6x squared plus 96 over x. And I'm just going to rewrite it. So my cost equation is 6x squared plus 96x to the negative 1. So right here is my cost equation. All right. Now I want to talk about minimum cost, so I have to do C primes. So I'm going to change this to C prime is going to be 12x minus 96x to the negative 2. So I'm just going to put it over here for x squared. And we have to put it equal to 0 so that we can figure out what that would be. So I'm kind of running out of room, so I'm going to come over here to the left. So I have 12x equals, now you're going to take this and move it over here. 96 over x squared. Cross multiply, 12x cubed equals 96. X cubed is going to equal, let me see now, x cubed is going to be 8. Raise each side to the 1/3. I get x to be 2, and I think we're talking feet. So I think that the base is going to be 2 by 2. All right. So I'm going to plug in the height. So 8 over 2 squared. And the height is also 2 feet. Well, that's interesting. This is a total cube. Now, before I continue on, I should make sure that the 2 in my C prime bar is actually a minimum. And remember, when you do that, you should put this right in your calculator right here. And look to the left and right of 2 to make sure it really is a minimum cost. And if you do this, you're going to see that it's negative here and positive signs here. So it truly is a minimum cost. So this is saying that it looks like our box is going to be 2 feet by 2 feet, and the height is also 2 feet. So it's 2 by 2 by 2 is the shape of this box. So I hope that helps. I'm going to do one more video on this, but I like this one. I like when we do cost equations. So